In this video, we'll talk about polar coordinates. So let's start with the vocabulary. So the pole is the origin of the coordinate system. So this is the pole. X-axis, the positive direction, is the polar axis. So this is the polar axis. R is the radial coordinate. So R, this, or this, or this, or this. Describes the signed or directed distance from the origin to P. So if this is point P, and as you can see, it's a sign, so it can be negative or it can be positive. Theta is the angular coordinate. Describes an angle whose initial side is the positive x-axis and whose terminal side lies on the ray passing through the origin and P. So this, it's theta, positive theta. This, because it's the angle with the going counterclockwise, it's negative theta. This, it's positive theta, while this is negative theta. So positive angles are measured counterclockwise from the positive x-axis. So let's note that in polar coordinate system, points have more than one representation because angles are determined up to multiples of 2 pi radians. So r theta, a point like this, can be represented as well as r and theta plus minus 2 pi. While the radial coordinate r may be negative, so point r theta and negative r theta are reflections of each other through the origin. Let's solve a few examples. Graph the points with the following polar coordinates. Give two alternative representations of the points in the polar coordinate. Let's start with the first one. So let's say we have 2 and pi over 4. So pi over 4 means 45 degrees. That would mean like half of this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be like 4.5. 1, 2, 3, 4, and half of this. This would be the angle, and 2 would be 1, 2. So the point would be this one. Let's call it point P of pi over 4 and distance 2. Now we have to write two more representations of the same point. So another one could be still 2 and pi over 4 plus 2 pi, because pi over 4 plus 2 pi ends up back here. So that would mean 2 and 9 pi over 4. That would be another representation. And also 2 and pi over 4 minus 2 pi, which makes it 2 and negative 7 pi over 4 would reach exactly the same point. Also, we know that if we have r and theta, negative r theta, it's exactly the opposite. So it's symmetric to the origin. So that means this point here, negative 2 pi over 4, it's symmetric, which makes it negative 2 and pi over 4 plus pi, because here we add a pi, getting back to the original point. So negative 2, 5 pi over 4, it's also another representation of point P. Finally, negative 2 and pi over 4 minus pi, is also right. So if we subtract pi, we go back to -2 and -3 pi over 4. That would make it another representation of the same point P. So we actually came up with 4 representations, 1, 2, 3, and 4 of the same point P. Now let's try another point, -1 and negative pi over 3. So negative pi over 3 is this way, and -1 would be, so 1 would be this way, so -1 would be the opposite. So this one, right, because this point here, let's make it 1, all this. So this point here would be 1 negative pi over 3. So this point opposite would be -1 negative pi over 3. So this would be the point that we want to write in other ways. So one way would be, the simplest one is just write -1 and write a multiple 2 pi. So we add 2 pi. That makes it -1 and 5 pi over 3. So it gets back to the point, as well as -1 and negative pi over 3 minus 2 pi. So that makes it -1 and -7 pi over 3. It gets back to the same point. Let's call it Q. Again, we know that r theta and negative r theta are opposite, right? So are symmetric, or reflection into the origin. So then let's draw it. Let's draw this negative. This would be 1 negative pi over 3. So then if we add pi to this point, then it would be 1 and negative pi over 3 plus pi. That would make it 1 and 2 pi over 3. And also, if we subtract pi, we get 1 and -4 pi over 3, another representation. So basically, again, we did more than 2. We got 1, 2, 3, 4. And finally, the third example, -4 and 3 pi over 4. So 3 pi over 4 is 3 times 45 degrees. That is 135 degrees. So it would be, let's say, 45, 90, 45. So let's say it would be here 135 degrees. And -4 would be opposite to this. 1, 2, 3, 4. So this point here would be the point that we are looking for. Let's call it R. So now let's find other representations of the same point. So we can say, well, -4, 3 pi over 4 plus 2 pi, or minus 2 pi. So this would give us -4 and 8, 11 pi over 4. If we subtract 2 pi, it would give us -4 and -5 pi over 4. But we can also say, well, the opposite of this would be this point here, which is 4, 3 pi over 4. So when we add pi to it, it would be 4 and 3 pi over 4 plus pi. It's going to give us 4 and 7 pi over 4. If we subtract a pi, it's going to give us 4 and negative pi over 4. So again, 4 representations of the same point. All right, so we are used to Cartesian coordinates, x, y, which we've used in math classes so far. But now, since we are talking about polar coordinates, and so the pair looks r theta, then how do we transform from one to another? So to go from polar coordinates to Cartesian coordinates, well, we use x equals r cosine theta. So given r and given theta, we can find x. And here it's a typo, y equals r sine theta. So if I know r and I know theta, I can find the x and y, so the Cartesian coordinates. Now to go from the Cartesian coordinates, x, y, to polar coordinates, r theta, then we are going to use r squared equals x squared plus y squared, right? If we square this, we are going to get the equation of a circle centered at origin with radius r. And to find theta, we are going to use tangent theta equals y over x. How do we get that? Well, just think about these two relations. If you divide y over x, you're going to get r sine theta over r cosine theta. Since r cancel and sine theta over cosine theta is tangent theta, that's how we obtain this relation to find theta. So let's do one problem. So it says express p of coordinates 2, 3 pi over 4 in Cartesian coordinates. So obviously r equals 2 and theta equals 3 pi over 4. So x equals r cosine theta, which means 2 cosine of 3 pi over 4. So that is 2 times, well, 3 pi over 4, that is in this quadrant, right? 3 pi over 4, so this would be pi over 4, the reference angle. All students take calculus, which means cosine in quadrant 2 is negative, so this is equal to negative cosine of pi over 4, which is the reference angle, which means 2 times negative square root of 2 over 2, which equals negative square root of 2. So we found the x, and now the y equals r sine theta, which means 2 sine of 3 pi over 4, which means 2, and now sine in the second quadrant is positive, the reference angle is pi over 4, so sine pi over 4, which equals 2 times square root of 2 over 2, which is positive square root of 2. So the Cartesian coordinates are negative square root of 2, square root of 2. So if you plot this point in the polar coordinates, it would look something like this. So this point here in Cartesian coordinates is negative square root of 2, square root of 2. It does make sense. Now let's try to solve going backwards. We do have Cartesian coordinates. We know that x equals 1 and y equals negative 1, and we want to find r and theta. So we know that x squared plus y squared equals r squared. So we get that 1 plus 1 equals r squared, so r equals plus minus square root of 2, and theta, we know that tangent of theta equals y over x, so tangent of theta equals negative 1, which means theta equals arctangent of negative 1, which is negative arctangent of 1. We know that tangent is odd function, so it's minus pi over 4. So now if I plot Q in the Cartesian coordinate, I get 1, negative 1. I know that its location is here. So now in polar coordinates would mean that the angle, it makes sense, is negative pi over 4, but the radius, since it's in this coordinate, it would be positive. So the since it's on the right side, the positive axis of x, it's going to be square root of 2 negative pi over 4. And one more example, let's convert the polar equation r equals 10 cosine theta plus 24 sine theta to Cartesian coordinates and describe the corresponding graph. So we need to find the x and y. If we start with r equals with the given equation, and we multiply both sides by r, we get r squared equals 10r cosine theta plus 24r sine theta. We know that r squared is x squared plus y squared, and we know that r cosine theta is x, and then r sine theta is y. So we get x squared plus y squared equals 10x plus 24y. This reminds us of the equation of a circle. So I moved all the terms on one side and I'm trying to complete the square. So here I'm going to add 25, which is half of this squared. And then here I'm going to add 24 divided by 2 is 12 squared, 144. But because I added on one side, I have to balance it. So that's 25 plus 144 on the other side. So the first 3 terms are actually x minus 5 squared. These 3 are actually y minus 12 squared and equals 169. This is the equation of a circle centered at 5, 12 with radius 13. So we did convert into Cartesian coordinates. We are using x and y, and we figure out that the equation is the equation of a circle.